Today, we are going to cover advanced workspace design. We'll be going over how to optimize the performance of your workspace and how to interpret the log file. We put a lot of work into making FME as fast as possible. We actively aim to make FME faster with each release. However, many bottlenecks are due to workspace design or transformer settings. In FME terms, performance means getting the results you need as quickly as possible while using as few system resources as possible. In today's session, we'll look at the variety of factors that can cause a bottleneck that slows down your translation. FME attempts to do all of its work in memory, but if there are enough features being worked on in a transformer, FME will start caching to disk. Disk operations are far slower than memory operations. Sometimes FME does not make use of all system resources if you do not have the correct license type or architecture type. We'll be sunsetting the 32-bit version of FME at some point in the near future, but at the moment, if you are using a 64-bit OS, well, first of all, make sure that you are using a 64-bit OS. You'll get better memory management from that. If you are using a 64-bit OS, you can use the 64-bit FME or the 32-bit FME. Which one you use depends on the formats you're using. Most formats, however, are supported by the 64-bit FME, so I do recommend sticking with that version. Also, there's little point in processing data you don't need. There are a variety of ways that you can limit what's being processed. The log file can give you hints as to the location of bottlenecks in your translation. Most log messages are on a single line in the log file, but sometimes the message spans multiple lines. Here we can see a single entry, but sometimes you end up with little block comments like this. Make sure that you've turned on the log timestamp option. We can see that right here. If you are going to be taking a look at performance, the timestamp information is always kept in the actual log file, but it doesn't show up in the log window by default. We'll take a look at turning this on in an upcoming exercise. The timestamp contains the absolute date, absolute time, CPU seconds to this point in the translation, CPU seconds for this particular message, and the message type. You can see an example of that here. The date, the time, CPU seconds up to this point, CPU seconds for this particular step, and the type of entry. There are 4 message types that you'll see: error, warn, inform, and stat. An error will halt the translation. In the log window, it'll appear as a red entry. A warn means that you should take a closer look at the issue, but the translation is not halted, and that'll show up as a blue entry. Inform just tells you that something has happened, like this, closing native map info reader. And stat gives you a count of features. There's a log debug option. It's a message type, which is an optional one. that will give additional log information, but you should only turn this on if directed to by safe support staff. We're looking to get additional information into your log file, but it puts a lot of useless and often confusing information into your log file as well. You can turn off logging of the different message types, but I don't recommend doing so. If something does go wrong at some point in time, you'll want to see those messages in the log file. If you're simply looking at cutting down or making it easier to navigate your log file after a translation, in the log window itself, you can filter by message type. And I find this is especially handy when combined with a logger transformer. With a logger transformer, you can specify what kind of message type it'll create. So I often make them into warnings so I can quickly grab them. The log file consists of 4 different sections. There's a command line statement at the very top. Then there's configuration and setup information, the translation and transformation itself, and then at the very bottom, a summary of the translation. So let's take a look at each part. At the very top of the log file, you'll find the command line, or the command statement that can run the workspace from the command line. So here we see an example of program files, FME 2019, FME.exe. Whenever you are running FME from the command line, I do recommend for the most part that you use an absolute path as opposed to just FME.exe. If you just use FME.exe and you end up having more than one installation of FME on your computer, it may end up running an instance of FME that is unexpected. Next up is the path to the workspace, and then any published parameters that you have, and we'll be talking about published parameters later on in the course. The published parameters are optional, but you can supply things like a different source data set or a different destination data set. Now that shows up in the log window when you run a translation. I'll quickly open up an existing workspace. So we've got this workspace here. When I run this, we can see that command line at the top there. The command line, however, is not stored in the log file itself, or at least I don't recall seeing it in there previously. So here's our actual log file. I'll open this up. So this is the log file, the actual log file itself, and you can see that the command line entry isn't there. You will notice that this log window does not show the timings. I have not turned those on yet. However, in the log file itself, that timestamp information is being stored regardless. So I'll stop that. So with this command line, I could just grab that. Copy it. This is just demonstration. And then from the command line, you paste that in, and you can run the translation from the command line. The configuration and setup information section provides useful information about what version of FME is being used, where it is installed, and what type of license is being used. So we can see it starting the translation. We have the release of FME. This part here is the date stamp for its release and the build number. I find that this is actually useful information if something's going weird, it's crashing or something like that. Sometimes it's useful to see if the release of FME that you are using is a particularly old one. If it's more than a few months old, it might be worthwhile taking a look to see if we have a new release. If you're running into a problem with a particular format, there's a good chance that someone else did too, and perhaps the problem's already been resolved. It can also be handy to see what architecture type is currently being used. If you have multiple installations of FME on your computer and suddenly your workspace isn't reading in the data or complaining about a reader or a writer, perhaps the architecture type of the FME being used is incorrect. For example, if you're trying to read in geodatabase ARC objects, if you're using Win64, it likely won't work unless you have ArcGIS Pro installed. Similarly, if you're using AutoCAD map object data readers or writers, you have to make sure it's Windows 64 and not Win32. Next up is the install folder of FME. This again can be handy information if you are running this from a command line or some sort of automated process. You may end up launching a version of FME or an installation of FME which is not the one that you actually wanted. It might be older or it might be the wrong architecture. And this information can point you to where you're going wrong. Next up is the licensing edition and type. If you're reading some of the formats that require a different license type, for example, you're trying to read from Small World or even just databases, perhaps someone changed the license type on you. If you're trying to write out to Oracle, you'll need at least a database edition. If someone changed the licensing type to be, say, a professional, then you wouldn't be able to write out to it. There's some additional information, such as the location of the temporary folder. Temp space is important. It's a good idea to inspect all system resource information. If you are low on temp space, if you have additional drives, you can specify a different temp location, either using temp or by using the FME_temp environment attribute or environment variable. You can also check on the operating system. If you're using a very old operating system, that can also cause some problems. With the virtual machines that you're using right now, these are using Windows Server 2016, I believe. And with those particular machines, I did have to update all the machines, otherwise there was a bug that would appear when you're publishing to FME server. But the Windows update solves that issue. If you're using something like, or if you see something here like Windows 7, that could cause some problems. If it's Windows XP, then you've got real problems. This will also tell you about how much memory you have available and when it will start freeing up memory, etc. So when you see freeing memory means caching to disk. And as I mentioned earlier, when things start caching to disk, the translation performance will slow down considerably. When FME does run out of memory and starts caching to disk more aggressively, you will see an entry in the log file indicating that it is freeing memory. I find that when that happens to me, it's usually because I've been running the translation a lot. I've cached up a lot of features, but I also have a lot of tabs open in my data inspector. If you are using the data inspector as a standalone application and are inspecting data frequently from the translations, you can end up with a lot of tabs. Generally doing a training course, I'll end up with 20 to 30 separate tabs, and each one of those is eating up a considerable amount of memory. When I see the freeing memory message in a translation, it's often fastest for me to actually halt the translation, then close down any applications which are using up too much memory, like the data inspector, and then restart the translation. When FME starts caching to disk, the temporary files will be created in your temp folder. The other folder that can go into is one specified by the FME temp environment variable. I'll just slack out how that's actually spelled because it is all uppercase, FME_temp. It is important to be aware of how much space you have available in the temp folder. Even simple translations can use more than 1 gigabyte of temporary space. If you have space available on a faster drive, you can tell FME to use that drive as the temporary folder location by setting the FME temp environment variable. This is especially useful if you have SSD versus HDD. Increasing the RAM gives you the most performance gain. After that, a solid state drive is considerably faster than the traditional spinning hard drive. When reviewing your translation log, it is important to remember that there are a lot of things happening in the translation at more or less the same time. So the log file doesn't necessarily list the actual order in which events occurred. The behavior of transformers can also mean that items are listed in the log file out of order. Some transformers pass features through immediately, and others hold on to features until it has all of them together. Personally, I find that if I'm trying to figure out the order in which things occurred, these counts are actually pretty accurate about the order. So if I do a run here, we can see that the zones are being read in first, followed by the building footprints. You can see how things are being held up here at the spatial filter. They're all being blocked before they go out to the attribute manager. Looking at the counts on the canvas does convey that pretty well, and it's certainly more accurate than what you would end up with in the translation log. There's a lot of information in the log file, but there are some log messages to be specifically aware of. The emptying factory pipeline means that FME has finished reading the data, and this gives you an idea as to how long it takes to read in your data sets. The unexpected input remover will tell you how many features were read that belong to feature types not defined on the canvas. If possible, avoid reading in features that won't be translated, but depending on the format, that may be impossible. This is the optimizing memory usage message I was talking about earlier. This means that you are hitting your memory limits and features are being cached to disk. This is an enormous performance hit. As I mentioned earlier, it's often a good idea at that point to halt the translation and then find any applications which are using up too much memory. The data inspector is a common culprit. Google Chrome can also be pretty bad. Close those down and then try the translation again. Freeing up the memory during the translation, I find, is ineffective. Once FME starts caching to disk, once it knows it's hit its memory limit, it doesn't continually check to see if memory has been recently freed up. Someone asked, how do I set FME temp? Or yes, FME temp. It depends on your operating system, but if you do a search for set environment variable, so you can see that you can do it in Linux or in Windows, set an environment variable, and there's instructions there. You can do it through the control panel. There is also a way of doing it at the command line. I believe it's a setx command. So the setx creates or modifies environment variables at the command line. Okay, so we got a little question here. How would you find the emptying factory pipeline setting in the log window? We could look for the color. It's the only message highlighted in red. That's not actually true. Let's just see if that's true here. I just ran a translation. I don't actually want to look for it. There we are, emptying factory pipeline. Definitely not a red entry. So that's not the correct answer. Looking for the message type. It's the first message of type stats. I don't know if that's true either. So inform stats. Nope, obviously not the first one. Use the log search tools. Well, you just saw me do that, so that's most likely it. And by opening tools, FME options to turn off all other messages. That's a terrible idea. Don't do that. Translation summary. This is at the very bottom of the log file. It'll tell you how many features have been read and how many features have been written. So this is just a reality check. Often a good idea to double check here. This can tell you if you're actually reading in the right data set, getting the features that you expect. The features written summary can be more useful. Sometimes total features written will be 0 if you've turned on some options such as redirect to data inspector. I should mention that the features read and written summary, I don't think that currently works with the feature reader or feature writer transformers. We'll take a look at that later on. But I believe that this will give you inaccurate information if you're using a feature reader or feature writer, or at least it used to. We'll see if we can test that later on. What I find more important is this line in the translation. This will tell me if actual features were being sent out, written out. This will show up regardless of the feature writer or using writers, I believe. But also this bit here, the number of warnings. It's always a good idea to review your warnings. If you're having a huge number of warnings, then the translation was far from successful. It's a good idea to double check why those warnings were occurring. It's also a good idea to double check your FME session duration. We'll talk more about the session duration in a little bit here. It is important to note that the CPU seconds are not the same as the actual translation time. For example, if I go into this translation here, this translation log, so this translation took 1 minute and 4.4 seconds, but only 38 seconds of actual CPU time. The other 30 some odd seconds were waiting for other things. Something also to watch out for when writing out features. The number of features written doesn't always mean that many ended up in the output file. It just means that many features were sent to the writer. The writer may still reject a feature if it is invalid. You will usually see that show up as a warning. It's always a good idea to inspect your final output in the data inspector. Just a show of hands, how many of you write out to geodatabase of some sort, file geodatabase, for example? A fair number of the class. When writing out to file geodatabase, it's important to ensure that you set the allowed geometry type correctly. If the geometry type which is allowed in a feature class is not the same as the feature that's being handed to it, as far as FME is concerned, that feature was sent to the writer. It'll show up as the features written out, but you'll end up with a warning from the writer itself saying that it actually rejected the feature because it has the wrong geometry type. I've also seen some situations where attributes had the wrong attribute type, and then those features were rejected as well. Yes, here's the warning. Feature reader and feature writer transformers are not included in the summary at the end of the log file. So again, it's important to note that the CPU seconds are not the same as the actual translation time. See an example of that here. So remember, it's absolute date time, the cumulative time, time for the operation, cumulative time, time for the operation, the message type, which we don't see here, and then the actual message content. So here we can see something like this, preparing a SQL query, sending the SQL query, and then this step took a while. Received initial database response, 18 CPU seconds. Okay, so that took a fair bit of time compared to the previous, 9 CPU seconds, bringing us up to 18 in total. So this took a much longer period of time, but in fact, it took far more than those 9 seconds. You can see here that it actually took more than 3 minutes. So there was a lot of processing that was happening where FME is simply not involved. So this translation itself took over 6 minutes, even though FME is reporting that it only took 25 seconds of processing time. What I'm trying to get at here is don't put all of your faith just in these times. Take a look at how these times are also going up. This brings us to exercise 1. Let's run an existing workspace and examine the log file and caches. The workspace is this one here. I'm going to copy paste that out into the chat as well. So now that I've copied it, I can open up Workbench, open, and paste that in. So the workspace we want is FME Data 2019, Workspaces, Desktop Advanced, Workspace Design, Exercise 1, Begin. Let's open that up. Now I'll want to see the manual as I do this. I'm just going to drag this off to the side here and grab my manual. So I'm going to collapse the table of contents so we can see more of the manual here. Workbench itself. Let's start moving some windows around. There. And I'll turn on the overview window. So this particular workspace, we're looking to find parks without existing art or no art within 100 meters of the park. So we'll open up the workspace and run the workspace. Actually, before we run it, let's turn off the feature caching. And we'll turn off the prompt for user parameters as well. So we'll run the translation and see how long it takes. Okay. So spotting how long it takes right now. Actually, it's still doing some processing there. We don't actually have those timings turned on. So it's difficult to see just how long this is taking. There we are. So that took about 32 seconds. But I don't see the start and end times. 4.6 seconds to the CPU. Let's turn on our log timings so we can actually see that information. To turn on the log timings, there's two places that you can go. The first is up to Tools, FME Options. And then go to, I can never remember which one it's in. I believe it's Translation. There we are, Log Message Filter. So that was a bit of hunting around. That's the first option for finding it. Second option, a little bit quicker, just clicking on the cog here. This will take you directly to the log options. Still have to expand the log message filter there. So there are some log settings. You can turn off the log file entirely. Don't do that. If you're going to be comparing multiple translation runs, sometimes the append to log file is useful. That will save every translation run into the log file, just appending onto it. Keep in mind that you can end up with a very large log file in this situation. And there we have our log timestamp information. So turn on your log timestamp information. And hit OK. And now we can run the workspace again. And now we see those log timings. So you can see the translation started at 9:37, 9:37:12. Well, that was much faster this time. and ended at 9:37:21. So that 9 seconds is accurate. You can see the CPU seconds. There's 4.5 seconds for us, 1.8 from the system. Add those together. It's roughly the 6.5. Now let's take a closer look at how our workspace works, how it's configured. Let's take a look at the navigator window. I have mine tabbed here at the bottom. So find your navigator window. Remember, if you've dismissed a window, you can always bring it back by going up to View, Windows, and there you can turn on your navigator. So we have 4 readers and 2 writers. We have a public art, Excel spreadsheet, Vancouver neighborhoods, KML, Parks Map Info tab, and we have our orthophotos GeoTIFF files. For writers, we have our Excel writer and our GeoTIFF writer. Looking at the overview here, we've got our first bookmark that contains the feature types for our parks, our public art, our orthophotos, and our neighborhoods. Now we can also inspect our data sets. Remember, you can always click on a data set and click Inspect, and that'll bring it up in the inspector. It's a good idea to familiarize yourself with the data just to make sure that it is what you expect it to be. Good idea to take a look at what kind of geometry you have, but also making note of the coordinate system information. Here we have our public art. Let's inspect that. So the public art here, we can see that we don't actually have any geometry at all, even though we do have a longitude and a latitude. With a reader like this, when I was first adding the reader, I did have the option of setting longitude and latitude to be the X and Y coordinates, and then I'd be able to set the coordinate system on the reader itself. That would actually render these 2 transformers unnecessary. So we're reading in our parks, our public data, reprojecting those into the same coordinate system. Just looking at the public art, it was latitude and longitude. The parks were not longitude and latitude. So the points for the public art had to be reprojected before an overlay could be done. We're then testing. Overlaps equals 0. We're seeing which parks don't have art. No art. If your workspace isn't immediately understandable at a glance, and just having a tester, we don't really know what that's testing until you go into it. Putting some indication there as to what this is doing is handy. We then prepare our data for the Excel reader. We sort it. We're sorting the parks alphabetically. Makes it a whole lot easier to look for a particular park. Some of the parks are actually multiple geometries, so we'd want to filter those out. Do some attribute management. Looks like it's just removing the unnecessary attributes. And then writing that out to our Excel writer. Forgot to mention here with the parks, we're also buffering out 100 meters because it's not just whether or not the art is within the park, it's is it within 100 meters of the park. So that's the upper stream of the workspace. The lower stream, we've brought in all of our ortho photos. We mosaic them together. That's because the vector on raster overlayer, if we look at the help for it, it's actually looking for, I believe, a single raster. So the ortho photos are brought in, mosaic together. The parks and the art are then overlaid onto that image. And then we clip it by the neighborhoods. For the neighborhoods, if we inspect this data set, we can see that this is in coordinate system LL84. Again, it's always important to keep in mind the coordinate systems of your data sets if you're going to be doing any sort of overlaying, like with the clipper. So we need to reproject. Again, reprojector 2. Don't like seeing numbers. This is specifically for our neighborhoods, so we might as well indicate that. So then we clip the features or clip the rasters by our neighborhood, set some no band data. In order to do that, there are parts of the clip data which have no data, or there's parts of the raster that are no data parts. The raster selector has to be done first because you need to select the raster, and then you can apply this to it to remove that. Those no data areas. Just ends up with a cleaner looking raster. And then we write this out to our GeoTIFF writer, and it is going to create a new GeoTIFF for each neighborhood. So we've run the translation. It's 700 lines long, so you don't want to read through all of it. But it's worthwhile looking at some specific parts. So you've got the command line to run this. This can be handy if you want to put this command line into a batch file, and then you can use something like the Windows Task Scheduler to point to that batch file and perhaps run this translation as a scheduled task. Next up, we have the configuration information, what version of FME we're using, things like that. This lets us know that we're working with a 64-bit version of FME. If you're dealing with rasters, you'll probably want that. They use up a lot of memory. Then there's some information about how much memory space we have available. Let's see, there we are. So how much memory or how much disk space we have. Again, remember FME can use a fair bit of disk space. I always have to be conscious of that when I'm creating these virtual machines. They're often a little bit low on disk space, so I upped it again for this year. How much memory we have available, and virtual memory as well. We can see it creating readers and writers. So creating a reader for format Microsoft Excel, I believe in the navigator, that is our first reader here. So the order in which the readers are opened matches the order in which they're shown in the navigator window. And if we do a search, we can find the emptying factory pipeline that happened at this point in the translation. So line 508. So everything before that is a bunch of reading. You can also find entries for the various transformers. Let's just look for the Raster mosaicer. If I could spell it right. There we are. So you can see the Raster mosaicer, and it'll give you some information about how many features it brought in, how many features it wrote out. Now, the order here in which you see them, this is the general order that they worked in, but you shouldn't rely upon this order. You can also see why, if you're looking at the log file, I prefer to rename the various transformers. If you have a lot of duplicate transformers, seeing reprojector 1, reprojector 2, reprojector 3, not particularly handy. Having some more accurate or descriptive name is useful. And then further down the translation still, you can find the entries for creating the writers. So all the data has been read in. It's now time for it to create the writers. And again, the writers are created in the order in which you see in the navigator. The Excel writer is created first, followed by the GeoTIFF writer. You'll also find, so this creates the Excel writer, does a bunch of stuff. Notice that there's still, it created the writer, there's still processing going on with various transformers. Now it's done with the writer, and I get this features written summary. We then create the writer for the GeoTIFF format, the GeoTIFF writer. That is then written out, and it gives us the features written for that writer. That means that any of the GeoTIFF features that got to the end first, I've got 6 features here, if those got to the end of the translation first, before the Excel features did, those GeoTIFF features are just held in memory until the Excel writer's finished. And that can increase memory overhead as well. Now, when I ran the translation the first time, you may have noticed that the unexpected input dialog popped up. It just tells me that I read in these 3 feature types with these 3 features, and they weren't defined on the canvas. These are just some additional feature types from the KML file, and they're safe to ignore. That also shows up in the log file with the unexpected input remover. Tests all of our features, finds that 3 of them were not matching feature types. There are things you can do during workspace authoring that shouldn't be done when the workspace is put into production. While authoring, the performance penalties of some of the transformers might not be as noticeable as when the workspace is put into production with much larger data volumes. I use logger transformers a lot for workspaces that are retrieving attributes from other sources, like a REST API call, or workspaces that I'm publishing to FME server, because I cannot visualize what is coming out of transformers that are being run on FME server. However, logging features to the log file does take time. When you're done authoring or troubleshooting your workspaces, I recommend that you disable or remove the various loggers. If you have a lot of loggers, it's easy to remove them. You can go up to the Tools option, Remove, and you can remove your various inspector or logger transformers. Feature caching is a huge performance hit. As much as I love feature caching, if you are running the translation in production, just by opening up the workspace and running it, be sure to turn it off. For example, our translation here that took, how long did this one take last time? 9 seconds in total. Let's turn on our feature caching. You don't have to do this yourself. I'll just let that run in the background while I talk about the next thing. Disabling sections. If you've disabled a section or a transformer, I would consider removing it entirely or making sure that you annotate as to why it's been disabled. If someone else has to troubleshoot your workspace, they shouldn't have to waste time considering what's been disabled, going over it, considering, is this why this doesn't work? So if you have unnecessary transformers, once you're moving into production, it's a good idea to remove those. Okay, so that took almost 40 seconds. So that's considerably longer. Before doing performance tuning, I do recommend running a few test translations and noting how long each section takes. Otherwise, you won't know if your tweaks are actually having an effect. For readers, note when the empty factory pipeline occurred. So we have the empty factory pipeline, which is happening here, 20 seconds. Well, remember, you can't really rely on this. You should be comparing this to the start of your translation. This might not be accurate. Now, it's important to note that running that in this translation here, let's see, I'm going to turn off the feature caching. If you are going to be checking your timings, make sure that all your translation runs have the feature caching turned off. I mean, that's a considerable performance hit in itself. Factory, oops, emptying. There we are. Emptying factory pipeline happened 2 seconds into it at 10:08:45. This whole thing started at 10:08:45. 42. Oh, so it's not that inaccurate. Roughly 2 to 3 seconds into it. But the message can be misleading because when FME is reading it in, it's not just reading it in, it's getting distracted. The first thing that we're reading in this workspace is, if I go back to my navigator, the public art. So a feature is read in. Before the next feature is read in, this feature is passed as far along the transformer pipeline as it can get. It will be passed along until it reaches a transformer which blocks it. So it'll come along here into the vertex creator. This is a feature-based transformer. It'll create the point geometry and pass it on to the reprojector, which then reprojects the data and passes it on to two places, a point on area overlayer. That'll hold it back because it needs to compare it to the areas. So the point comes in, the point will go no further. But it'll also go along here, 2D ellipse replacer, feature color setter, all the way to our vector on area overlayer, where it'll be held up again. So the feature will go through all of this processing before the reader reads another feature. So these come in and go as far as they can. So that emptying factory pipeline, that's not just showing how long it took to read this, it's how long it took to read this and pass that feature along. So if we disable the transformers and run the translation again, we can end up with a very different amount of time because it's not performing those actions. With the writer performance, again, the easiest way to find your writer performance is to run the translation, then disable your writers, run the translation again. It takes a little bit of math. So we take see how long it takes to run the translation all the way through, see how long it takes to run the translation without actually writing out any data, and then you have it, by doing some math, you can see how long it actually took to write the data out. So this example here, we run it all the way through, took 26 seconds. We then disable the writer, run it again, 26.1 seconds. The difference of those is how long it actually takes to write out the data, 0.1 seconds. Assessing the transformer performance, again, that's just some more math. We know how long it took to run the translation without the writer turned on. Disable all the transformers, run the translation again. Now we know how long it took to read. Subtract all of those, how long it took to read, how long it took to write from the total running time, and now you know how long it actually takes to transform the data. Now things can become a little bit more complicated if you have feature readers or feature writers. I find that the biggest performance hit with the feature reader is the fact that each feature that comes in initiates the feature reader. Usually if you have multiple features coming in, you often don't need those multiple features. If we're doing a spatial filter here, aggregating those together and doing a single initiation of your feature reader will be much faster. So if you're using a spatial filter in your feature reader, you have multiple features coming in, consider an aggregator transformer. Okay, let's take a closer look at our workspace from the previous exercise. So colleagues created a workspace to analyze the amount of art in each city park. We're carrying out a code review to ensure that the workspace is efficient and well designed. Let's open up the starting workspace here, just in case we messed anything up from the previous one, but it should be largely the same. I'm going to copy paste this out into the chat, and we'll open up that particular workspace. So that is FME Data 2019, Workspaces, Desktop Advanced, Workspace Design Exercise 2, begin. Okay, so it looks to be the same workspace. Let's take a look at the navigator. Everything seems to be in the same order. So let's start testing for its performance. The first thing that we'll do is make sure that the feature caching is turned off. If you're doing performance tuning, again, those various transformers that hurt performance, like inspector transformers, logger transformers, those should be disabled or removed. Quick glance through our transformer list. It doesn't suggest that we have any loggers or inspectors. Let's run the translation. So the translation for us took 8.4 seconds. I did notice that last time when I ran it again, it seemed to run a little bit faster. Sometimes running it more than once might be worthwhile. Sometimes there's a variety of performance things that can affect performance. If it's a quick translation, maybe running it again just to see how it varies over time. So this translation took 8.7 seconds. Now with the caching turned on previously, we saw that it took almost 40 seconds. So it's about 5 times as long. Now let's assess relative performance. So first we're going to disable all components after the readers and run the workspace. Now that doesn't mean we have to actually disable everything. Just the first line there actually would suffice. So this bit here. What I can do, I'm just going to drag a fence over all of this. Actually, the first bit here, as I scroll down, it should allow me to scroll. So I've selected everything there. I can then put a bookmark around it. Control B. So I just put a bookmark around all of that. Oh, I want that reprojector too. What I want to do is put a bookmark around everything, which is the first thing the readers go into. So there's no feature connectors going around that bookmark. I can then right click on that bookmark and I can disable everything within the bookmark. So if I right click on the bookmark, I can disable all objects in the bookmark. And the other option was to go through and just click on each of these connectors or just click on each transformer. Putting a bookmark around it just makes it easier later on to turn it all back on. All the rest of this can still be turned on because things are only activated, instantiated, I guess, when a feature actually goes into them. So if we look in this log file, there's no writers being initiated. At least there shouldn't be. Let's see. Writer. Creating writer for format. No. So it doesn't actually create the writers. Just readers, multi-writers. Yeah, that's it. So we don't see anything about our GeoTIFF writer or our Excel writer being created. Okay, so we run that and our translation took 2.8 seconds. So now we know it takes 2.8 seconds to read in all of our data, and then roughly 6 seconds for the rest of the translation. So now we want to run the translation where we just disable the writers. So we have this bookmark, which is disabled everything. We can just right click on that again, and we can enable all objects in the bookmark. So go ahead and enable all the objects in your bookmark. It should be like this. Another option, if this was just for performance tuning, would be just to hit Control Z or Control Z a few times. This will put everything back the way it was. And now we want to disable our writers. All the writers are in, or all the writer feature types are within this bookmark. I could disable the writers in the navigator. So here's my two writers. I could just right click on them here and disable them. But that's 2 clicks. Here I can just click on the click on the bookmark and disable all contents in the bookmark. Again, because the features don't actually arrive at the feature type, those writers should not be activated. So that took 3.3 seconds. So the reading took 2.8 seconds. The writing took 3.3 seconds. That brings us to 6 point something. So it takes about 2 seconds to go through the actual transformation. So ultimately, the writing is taking more time than anything else. And we see that here as well. Actually, sorry, it's not even the 3.3 seconds. The transformation is the previous time before I was reading was 2.8 seconds to read, 3.3 seconds to do everything but write. So it's actually only half a second to do all the transformation. So the transformation is actually pretty quick. The writing takes a long time. So if we're going to do any performance tuning, we'd get more benefit by speeding up the writing. And we'll take a look at that in the next exercise. A couple of tips for improving reader performance. If possible, only read in the features that you actually need. You can see in this example here, We're reading in postal addresses. There's 13,000 postal addresses, but we only care about ones where the owner name begins with the letter C. There's only 419 of those. It would be much more efficient not to read in those 13,000 features, just to read in those 419. Some formats do allow you to specify a where clause. I believe this would actually be one of them. This is our file geodatabase, and I believe if you select the correct reader for that, there's a where clause, and you can just ask for those features. Sometimes you're only interested in features that are within a certain area, so there's a search envelope that you can often use. Whether or not that improves performance does depend on the format. There has to be a spatial index, usually it's a database, and then that can speed things up. For testing, there's also the features to read. You can tell it to just read in a certain number of features. I can't think of many situations in production where you'd just be interested in like the first 10 features. But for testing, this used to be quite handy. Although nowadays I find that using the feature caching allows you to work with a more representative data set without having to go through the performance hit of rereading the data every time you run the translation. Here we are in the feature type. This would be with the postal addresses. Look for things like a where clause. This is a lot faster than reading in everything and then having a tester. So now you can see here that instead of reading in the 13,000 features, we only read in 419 features. When reading from databases, I find that if you can push some of the work to the database, that can speed up the translation a lot. Databases are often optimized for these kind of, I guess, process. So if you're reading from a database, perhaps using a SQL caller instead of the database reader itself, that allows you to push much more of the work to the database itself. If you need to sort the data, you can ask the database to do that, things like that. Excess feature types. If you're reading in an AutoCAD file or some of the file-based formats, whether or not you have the feature type defined on the canvas, that feature type and all of its features are going to be read regardless. So removing that feature type won't improve performance. It will declutter your workspace a little bit, so that's nice, but it's not a huge performance gain for the file-based formats. However, with the database formats, these feature types which are defined but not used, they are a performance hit, because with a database reader, we'll only read in the feature types, the tables or feature classes which are defined on the canvas. If I have my postcode boundaries defined on the canvas with a database, it'll read that in, and it didn't have to. If I just remove that feature type, then that particular table will not be read from the database. If you have a lot of them to get rid of, again, under Tools Remove, in addition to removing loggers and inspectors, you can also globally select everything which is unattached. This is handy if you have reader feature types that aren't connected to anything or writer feature types that aren't connected to anything. Now, it doesn't just globally remove them the moment you click on unattached, so you don't have to worry about that. When you click on that, it'll actually bring up a list, and then you can choose what you want to remove. There are some avenues for performance improvement that are external to FME, such as getting faster drives, faster hard drives, or ensuring that other processes are not occurring at the same time. For example, on my computer, I have a Dropbox syncing app, which seems to eat up a lot of CPU and memory at inopportune times. So quite often, if I turn off my Dropbox syncing, sometimes that will speed things up. Also, if you're writing out to a folder which is synced somewhere in the cloud, if it's trying to do that syncing process while you're writing out to it, that can slow things down as well. File system improvements can also be handy to just ask for improved hardware. If you're still using a spinning hard drive, you could probably get some much better performance with a solid state one. When writing to a database, dropping the tables and then rewriting them is often faster than updating the tables. If you're updating a huge amount of data, quite often it's faster just to read in the entire original database, add the additional features, drop the original table, and just rewrite the whole thing. Indexing can also slow down a translation. If you can do that as some sort of post-translation process at another time, that can help performance. FME uses the writers, writes out to the writers in the order in which they are listed in the navigator. And FME has to be done with the first writer before it can go move on to the second writer or the third writer. Any features destined for a later writer are queued in memory and may be cached to disk. So always list your writers with the largest output first. Setting the writer order, that's easily done within the navigator. Just grab your writer and move it up in the list. Same thing for the readers. You can drag and drop them around in the list as well. Now there is a way of changing the order based on the features as well. So you can order the writers either by the position in the Workbench Navigator, that's the default. Another option is that the first feature that reaches a feature type, that determines the order of the writers. So if my Excel writer got a feature first, then it would start up that writer and start writing out the features. And then the GeoTIFF one would have to come afterwards. But if the GeoTIFF, or if my Raster got to this feature type first, then it would write out first. Okay, so given this screenshot here, which should we make the first writer in this workspace? We have writer A, this is parks, probably polygons. There's 800 polygons writing out to parks. Next up, we have address points. We've got 135,000 address points, almost 136,000 writing out to postal address. And next we have 18 postal code boundaries, and this is tabular records, no geometry at all. So we have polygons, points, no geometry at all, 800 features, 135,000 features, 18 features. So which one should we set to be the first writer? Writer A, writer B, writer C, or we don't know? Choose your answer. The answer is we don't know. Yes, we have a huge number of points here, but we don't know how many attributes there are in this or how large those attribute values are. Could just be a first name or an address. So yes, there's a lot of points, but points don't take up a lot of space. We don't know how many attributes there are. We have 800 parks here, they're polygons. They could have a huge number of vertices. They might even have a huge number of attributes with very large attribute values. Same thing could be happening here. Yes, we have no geometry, but we could end up with a very large attribute in there, perhaps huge attributes, and that'll eat up more memory or space on disk. So ultimately, we don't know until we examine the outputs or try them in different orders. Optimizing transformation performance. There are often settings in the transformers that can have a large effect on performance. So be familiar with the various transformer properties. For example, in this clipper, I have this clipper type here. This doesn't really jump out at you as being a performance option. Multiple clippers, well, I've got 6 features coming in. It's going to have to be multiple clippers. But if I click on this, there's this option here, clippers first. Now, for this particular translation, this would make no difference whatsoever. I only have a single feature coming in. But if I set clippers first, well, let's actually just talk about this a little bit. With a transformer like the clipper, all the features, all my clippies and my clippers have to be within this transformer before it can pass the next feature out. So it's going to be storing all the features in memory. And again, as I mentioned, if you eat up all your memory, you're caching to disk, that hurts performance. When I turn on clippers first, then as soon as the first clippy comes in, it shuts down the clipper port. It ignores it. It stores those 6 clipper features in memory, and then as each clippy comes in, it'll be clipped and passed out. So the memory overhead for this doesn't get any higher than just the clipper features, and the clipper features and 1 clippy. So it greatly reduces the memory overhead if you have a huge number of clippies. I've only got the 1 clippy here. Telling it to be clippers first does nothing for me. But if I had 20 million clippies, then this could improve performance substantially. So be aware of your data volumes. Now the next trick is I have to make sure the clippers get here first. If I have to use a feature holder to hold back these ones, then I've just moved my performance hit into a different transformer. It has to be the way it's read in. So if I wanted to make sure that my neighborhoods got to this transformer first, in the navigator, I would just move my neighborhoods further up the list. Oops, I was moving that one up. There it is right there. So if I put that one up first, then I can be confident that the neighborhoods will be read in first. They'll go through the reprojector and to my clipper and get there first. Now, if I had a clipper again over here, then the ordering, you have no control over that with the readers. Or if I'm doing some other group-based processing before the clipper, that can wreck all of that. Or at least make the ordering much more difficult to predict. Now, also the order in which you are transforming things. For example, here I have my area calculator, statistics calculator, and a tester. If I am testing on things which are created by my statistics calculator, that might be a good place to do it. But if I'm testing on something else, not something created by the statistics calculator, maybe I should put the tester before the statistics calculator, or maybe even before the area calculator. If I'm going to be filtering features out, there's no point in performing actions on features which aren't going to be used. So filter, remove, and then do your actions. Always be looking to remove data volume first. Also remember, I haven't seen that mentioned here. I may have skipped right over it. When you have a lot of attributes, like that's not a lot. Orthophotos wouldn't have much, neighborhoods. So these ones don't have a whole lot of attributes. But again, you don't know what the attribute values are. Any attributes that you're not going to be using when you have large data volumes and transformers that are going to hold things in memory, use an attribute remover or an attribute keeper or an attribute manager to remove unnecessary attributes. It will remove the memory overhead of these blocking transformers. So in addition to just removing features, removing attributes from features can also be important, especially if you have lists. Lists have a huge memory footprint. So if you've created lists, list attributes, and you're not going to use them, get rid of them. I've had translations. First time I noticed that, I had a translation that was taking about 10 minutes. I had a couple of lists on the features. It wasn't even a huge data set. So it was around 10 minutes or so to run the translation. I dropped the lists. It dropped it down to about 3 minutes. So it made a huge difference. The group by mode. So quite often you'll want to group your data together using a particular attribute. We now have this group by mode. This is a combination of some of our older options here. We can either process at end, where it's blocking. This assumes that we're going to need all of the features in here before we can group by this particular attribute, or process when group changes. This means that your data is ordered by group. As soon as a different value for our zone category comes in, we're telling the transformer, if you get a new value, assume we're done with the previous group. You can then do the transformation on that, pass that out, clear out your memory, and start again with the next group. The trick is your data has to be ordered by that group value. If it's not, then it's just not. Don't try to put a sorter transformer in. Again, you're just moving the performance hit into a different transformer. If you're reading from a database and the order is not grouped by this zone category with a database, if you use a SQL caller transformer, quite often, depending on the database, when you're doing a SQL query to retrieve the data, you can ask the database to sort the data for you. And then you can make use of this process when group changes. But that depends on the database and your familiarity with SQL. Features first parameter. Again, this is like the clipper. Quite often you'll see something like areas first or lines first. Again, that takes your group-based, your blocking transformer, and makes it slightly less group-based. It'll only be group-based on a particular port. In this case, this would be a point on area overlayer or some area overlayer. If I'm telling it that the areas are going to come in first, by the time the first point gets there, that means you're done with the areas, and then just deal with the points on a feature by feature basis. Again, that can improve performance greatly if you have a huge amount of one type of geometry, in this case points, and relatively few areas. So always take a look at the various transformer parameters, because sometimes those options can be hidden away. Areas first might not immediately jump out at you, but quite often if you have a blocking transformer, there's something that'll indicate deal with this type of geometry or this type of feature first. As I mentioned before, the attributes and transformation. If we have a lot of attributes here, these are taking up a memory overhead. Get rid of the ones you don't need. There's two ways you could do this. One is to read them all in and then use a transformer to remove the attributes you don't need. The attribute manager, attribute keeper, attribute remover, things like that. That works well with formats where it has to read in the attributes no matter what. But sometimes on the source feature type, you'll see the attributes to read, we have this read in all attributes or only the exposed attributes. If you unexpose them, it won't read in those attributes, but it has to have this option, exposed attributes. If I go up here into my parks here, open this one up, user attributes, notice it doesn't say that. This depends on the reader. Generally speaking, the database readers will allow you to just read in the attributes you want, and that's fantastic. The other formats, in this case, map info tab, if I unexpose these, it's still reading in those attributes and they're still showing up on the features, they're still taking up memory. The only thing I can do at this point is to then run it through an attribute remover and remove what I don't need. Like this. Again, as I mentioned earlier, list attributes are attributes that have a numbered array of other attributes within it. So you end up with a lot of attributes really quickly, eats up a lot of memory. If you're not using a list, if you're done with a list, get rid of it. Okay, your geometry. Sometimes, I haven't run into this very often, sometimes you don't actually need the geometry. If you don't need it, get rid of it as quickly as you can. Because just like lists, geometry is often very large and complex and it can take up a lot of resources. The geometry remover will take care of that for you. For the sake of time, we'll skip over that little quiz and move on to exercise 3. Okay, so we can continue on with our previous workspace here. First of all, we'll want to see if there's anything we can do with these various transformers. For example, with the parks, with the user attributes, could we reduce the amount of attributes that we have here? And it doesn't really help us there. We could add an attribute remover, might improve the performance of the point on area overlayer, but it all depends on what attributes we want on the final output. So let's see, it's going down here. We have an Excel writer. Oh, I should re-enable that. Let's enable our writers. So we have our writers. We only care about these attributes, so getting rid of some of the other attributes could speed things up. Next up, checking the neighborhoods. If we do anything here, again, we can't hide any of those attributes. We could remove any unnecessary attributes, depending on what we have being written out here, because we are fanning out on the neighborhood name. So we could delete anything other than neighborhood name. So that would be an option. With the public art data, take a look at what we have here, user attributes. Oh, so we could get rid of something here. But I think we certainly need the latitude, longitude, and latitude because we're using those to create the geometry. The name and title. Let's see, do we end up using those anywhere? That's probably the artworks. Oh, that's the count of it. So perhaps we could get rid of those attributes if we don't actually need them. We also need all of the data. We've needed all the data for all of those so far. The ortho photos, do we actually need all of those? Let's inspect this. Let's view the source data, because we got 40 ortho photos. That's a lot. See, it's taking a while to do a visual preview. Doing the visual preview that way may have been a mistake. Let's give that a moment to figure itself out. Oh, there we go. We should probably open this up in the data inspector itself. It'll make it a little bit easier for us to see what's going on. So let's open the data in the data inspector. You can see I've got a lot of tabs here. So you have a fair bit of them. If I click the open again, I can change how I'm reading that in. Oh, I know why it's doing that, because I opened it up. It's actually giving me each separate tile as a separate tab. That's interesting. Okay, so I can see that I have a lot of separate files. Could also just hit open again. Usually it gives me what I used last time, but anyways, the gist of this is we have a lot of separate files. Actually, it does want us to compare them, so let's actually do this. So let's hit open here. I'm going to open up GeoTIFF. The reader data set, I'm going to select multiple files and folders. So with the drop down there, multiple files and folders. I'll add files. Actually, I can add folders. Let's add folders. Add folders, and the one I want is /FME Data 2019 /data /ortho photos. If I just choose that folder, it gives me all of this. So it'll read in everything from those folders. And for the parameters, I will get it from the file name. So feature type names from the file name. So when I open that up, I can see all of my individual files. And then we can add to this the neighborhoods, because ultimately we're only interested in the imagery which is within a neighborhood. If we have imagery outside of a neighborhood, we don't need that particular GeoTIFF file. So let's add to this our KML file for our neighborhoods. And that's this one here, FME Data 2019 Data Boundaries, Vancouver Neighborhoods.kml. So we've added to this view, Google KML, /FME Data 2019, /data, /boundaries. And in the boundaries folder, we have our Vancouver neighborhoods. I'll give everyone a moment to grab that. So I'll hit open. And we can read that in. Oh, wait. Read from source. I may have to read some of this back in again, depending on the coordinate system. Different coordinate systems. Now, this detected it as UTM-83-10. This would have detected it as LL84. That's good. Now I don't need to set the coordinate system. I can just bring in a background map. So let's bring in a background map so that they'll be in the same coordinate system. To bring in your background map, we've done this in the desktop basic course. Go to Tools, FME Options. It has changed slightly for FME 2019. We need to add a background map. So under Background Maps, hit on the plus sign. We'll use the Stamen maps. We'll call it My Background Map. Our map list here, we'll use terrain. Save that and hit OK. I should turn on my background map. No, sorry, I've added a background map, but I haven't actually applied it to this. Tools, FME Options, there we are. Select the background map. Oh, it doesn't show up on the current one. Background map, there we are. Background map off. Right click on your view, background map. There we are, stem and terrain. All those error messages that are going by, it's because I told it to look for specific extensions. A lot of those extensions aren't being used. So it's just telling me, hey, I didn't find anything of .ovr. So here's all of our various tiles, and then the neighborhoods over top of it. So you can see there are, in fact, a lot of TIFF files that we're reading in that we don't need. So this guy right there, for example. So 0405JK, we don't need that one. No point wasting time reading it in. So what could we do to speed that up just a little bit? Well, maybe just read in the data that we actually need. This might work. So let's change our GeoTIFF reader to a feature reader. So we'll delete this feature type here. So with your ortho photos, select your feature type, delete it. It'll tell you that you're deleting the final feature type. Do you want to get rid of all of them? Yes, we do. Next up, let's drop in a feature reader. So type in feature reader and drop that inside of where your ortho photos are. We now want to connect that feature reader up. I'll give everyone a moment to finish getting that in there. So we have our reprojector. We feed that as the initiator into our feature reader. Now we can't connect this feature reader up to an output just yet because we don't have the ports we want until we've actually sampled the data. So let's open up the feature reader parameters. Feature reader, again, this should be an indication of what it is we're reading in. This is our feature reader for our GeoTIFFs. So feature reader GeoTIFF, otherwise just says feature reader, you have no idea what it is. I mean, the bookmark helps a little, I guess, but I still like having feature reader GeoTIFF, especially if you have multiple feature readers in the transformer, in the navigator, makes it easier to find the one that you want. The format, GeoTIFF. The data set, we'll select all of them again. So we'll open up the file browser. It's in FME Data 2019 Data, Ortho Photos, and we can just select all of these, Control A. Using a wildcard would probably be the better option, but we'll just do that for sake of time. Parameters, we want to group them together by the format name. Otherwise, we're going to have a lot of ports here. So we've got them all selected, and now we want to just read in the stuff that intersects the results. So initiator intersects result. Output port. We may, and this should be sufficient. We may need to come back here later on and deal with the attribute accumulation, but we'll see what happens first. There we are. So now I have my GeoTIFFs, and I can connect that up. So let's run this and see what we get. So we get 48 features output. That's because some of the neighborhoods overlapped the same GeoTIFFs. So we ended up reading in actually more of them than we did before. Before, our translation took only 8.7 seconds. Now it takes 14 seconds. Okay, so also each time these 6 features came in, it's initiating that reader. So it's initiating a reader, initiating a reader, initiating a reader, and that takes time as well. So what could we do to make things faster? We could aggregate this, make it an aggregate feature. The feature is somewhat more complex then. If the features weren't touching each other, the aggregator would be the right thing to do. In this case, the neighborhoods all touch each other, so a dissolver would actually be better. So let's drop a dissolver in there. Try to keep your workspace as tidy as you do it. I know I'm not doing that right now. That is not best practices, but I'll drop in that dissolver. We don't actually have to configure anything in there. So drop in a dissolver before your feature reader. Run the translation again. Now we'll see those 6 features go into the dissolver, will get dissolved, and only one feature initiates the feature reader. And now we only get 27 features out. If you're just looking at how long it took to read the features, I mean, we still had to read in all of those GeoTIFFs because the feature reader has to read them all in before it can do any sort of selection. But once it's selected them, that does reduce the amount of work that the raster mosaicer has to do. So that does or should improve performance a little bit. Not that much. So now it's taking 11.1 seconds instead of 8.7 seconds. Yeah. Now, maybe if we had larger data volumes or different data volumes, that would be more worthwhile, but in this case, maybe not. Just want to take a quick look at some of the feature reader options here before I went any further. Someone had asked the question earlier if we could just use the bounding boxes of the imagery. In this particular situation, we do need the imagery later on, so just reading in the bounding boxes probably wouldn't work for us. I was just thinking though that sometimes you have raster catalogs, which are simpler vector files, polygon files, that then contain the location of the raster itself. Now, if we had a raster catalog, maybe that would be a faster way of doing it. We could clip against the vector data set, which contain the raster catalog, get the raster names, and then in another feature reader, we can use that attribute value of a raster catalog file path name for the data set here, and then just read in what we need. So if we had a raster catalog, that might work. I'm trying to think if there's anything else in here. So initiator, maybe bounding box intersects, but with the shape here, the bounding box would probably then encompass everything. So I don't think that that would actually make much of a difference. The bounding box there would be the bounding box instead of the raster. It would be the bounding box of the neighborhoods. Would be a simpler geometry if that ends up being the bottleneck. Let's give it a shot and see what happens. Well, it comes down to it. If you're unsure of something with FME, try a translation. Oh, we got 36 features out this time. I think that still the same amount of time. So that didn't actually make much of a difference. Now this brings up an interesting thing. A writer option that we have. Oh, sorry, you got to check the writer order first. Okay, so we have the writer order. We're writing out the Excel spreadsheet first. The geotiffs are larger, most likely. So perhaps we'd want to write that out first. That could remove some of the memory overhead, or if we're caching things to disk. So let's run that and see if that makes anything better. So all I did was take my geotiff, I dragged it up top there, and then ran the translation again. Shaved a second off. So it looks like being able to write the geotiffs out directly does in fact speed up the translation a little bit. So it shaved a second off the translation. Now for at this point, 11-second translation, that may not sound like much, but earlier we figured out that the writing step for this translation was taking 3.3 seconds. So if that still holds true now, then instead of just taking a second off of 11 seconds, we've taken a second off of 3 seconds. And that's a considerable improvement. Another thing that we could take a look at are some of the options for the writer. Right now with the Excel file writer, every time we write the file out, if I go to the properties of the writer here, every time we write this out, we are deleting the file and writing over top of it. And deleting the file takes some time. So maybe, well, let's set that to not overwrite. And instead, we'll tell the writer just to truncate this particular feature type. So if I go into the feature type settings now, I can go to, there we are, writer mode, insert, update, delete. Sheet settings, there we are, drop existing sheet and range, truncate. I don't want to drop it because then I'm deleting the sheet and recreating it. I just want to drop all the data within it. It's probably the fastest action that it could do. And let's see if that makes an improvement. So just to recap there, I went into the properties of the writer first. That's this button here. And under writer parameters, I turned off the overwrite existing file. And then I double-clicked on the feature type to see the feature type properties. The writer mode is still insert, but the drop and truncate here, drop and truncate, I truncate the existing sheet. Let's run that again. Before it was taking 10 point something seconds. Let's see if we can drop this down into 9 maybe. I did see a memory error though, 10.4. Let's take a look at my warnings. Failed to free sufficient memory to reach the process usage limit. If we're having memory issues, closing data inspector can often help with those. So there we are, 8.9 seconds. That might actually have more to do with freeing up the memory of having the data inspector open than just the setting here. Let's turn that back on to see. Septic 8.9. If I turn this back on, you don't have to turn it back on yourself. You probably didn't have the same problem I had. That was actually faster, 8.4. The other thing to keep in mind is that the speed of the translation often varies by about a half second in either direction whenever you run the translation. Someone else, it's only taking 2.7 seconds. Make sure you don't have feature caching turned on. If it's going that fast, I would expect feature caching to be turned on. Or someone's got a much faster computer, which can also happen on these Amazon EC2 machines. As I'm running this, I'm using up CPU credits. And if I'm running it a lot, maybe I'm burning through those. The other thing to keep in mind is that as I'm polishing these transformers so that they run faster, we've already established that the transformation part of the translation is only taking 0.5 seconds anyways. Some other things that can improve performance: upgrading existing transformers. Sometimes we improve the performance of the various transformers. Before I do that, I'm going to go back in here and truncate, yes. Drop, no. So as we come up with new versions of the transformer, sometimes the new ones are faster. You can find them in the navigator. In the navigator, we have our transformers, but we also have a subsection of upgradable transformers. We can see here that we have a clipper and a point on area overlayer. Both of those can be upgraded. So if I right click on this guy, I can show the changes. So what it did, removed deprecated aggregate option, added group by mode to enable processing at each change in group. There's the transformer itself, and here I can choose upgrade transformer. Automatic transformer upgrade, yes please. So this shows the parameters in the old one. This shows the parameters in the new one. Notice that the group by mode has changed slightly. We'll hit OK, and that'll upgrade that transformer. We can also see what's changed for the point on area overlayer. Show changes. So we've removed parallel processing from the transformer, renamed input order to group by mode, and improved performance on the group by mode process when group changes. Maybe we can make use of that. Let's see, let's upgrade the point on area overlayer. So we can see here we had parallel processing as an option. We've removed that for FME 2019 because it turns out it was very rarely actually improving performance. And we've improved the group by. Now this group by mode, process at end, this is the input ordered, yes or no. So this is just a more descriptive way of stating the same thing. Now, is there any point in grouping these? No, I don't think there is. Okay, transformer order. We have a sorter and a duplicate filter. Let's see what the options in the duplicate filter are. Input is ordered, yes or no. Seeing that we just sorted it, we could say yes. That might remove the memory overhead. So let's see what that does. Let's change that first and run the translation. Again, we're not going to be seeing huge changes here. The other option would be to put the sorter after the duplicate filter and then sort fewer features. But again, I don't think that's going to make a huge amount of difference. Okay, can the tester or duplicate filter be moved earlier in the workspace? The duplicate filter, could we move this elsewhere? We still want all of our features for everything other than the Excel spreadsheet. So the duplicate filter could be moved before the sorter, depending on the settings of the duplicate filter, but it couldn't be moved any further than that. We couldn't put it before the tester or anything over here because we need all of those features for the other parts of the translation. Could the tester be moved earlier in the translation? What's it testing? Overlaps. Well, it's testing overlaps, so that's right after the point on area overlayer. So when it all comes down to it, tester can be moved. Nope. Duplicate, nope. I'd say, I guess originally the duplicate filter could be moved. I'm going to go with neither then. Yeah. Okay, and the rest of this exercise is just looking at the various parameters within the transformers. Again, as we found earlier, the transformers aren't the main bottleneck here, but perhaps you could move features through a little bit faster. The clipper transformer, multiple clippers to clippers first, but that's not going to make any difference here because we only got one feature. So that really wouldn't help us. Point on area overlayer, this might help. So I could tell this in the point on area overlayer, areas first, yes. And then as each point comes through, it's not going to be held there. Now the trick is we have to make sure that these areas are read in first. So the navigator, the parks, has to be up near the top. So then when you run the translation, we might even be able to see it. Those areas come in, and then as each point goes in, they flow right through. But there's only 185 points. That's not a huge amount of data. Now, if there's 185 million points, then that would probably be worthwhile. But 85 points, not so much. If you fail to order your data first, all of your points will come out through the rejected feature port because your points got in there first and there were no areas. So no overlapping happened, everything's rejected. Actually, sorry, it's not the points, it's the areas that come in and are rejected, or perhaps a combination of the two. But in any case, features are going to be rejected because the areas came in last. So that's why we reorder it. So those are some of the things that you can play around with when you want to improve the performance of your translation. As you see with ours, ultimately, I didn't make things considerably better. 11 seconds there. Seems to be taking a little bit longer every time I do this. Yeah, 9 seconds that time. When we first started with the Workspace, it ran at an 8.7. So your mileage may vary. But with much larger workspaces, all those little tiny things that are affecting my translation, such as me presenting this. I mean, I do have GoToWebinar running at the same time, and that's currently streaming everything. That in itself is taking a fair bit of memory on my training machine. So I've got a few other things which are slowing things down here. I do have Google Chrome open as well. That can eat up a lot of processing resources. So there are other things here which could be slowing down my translation other than FME itself. With larger data volumes, when you experiment with these things, you may find stuff which makes a larger difference for your data volumes. So that was just some of the things that you can try to optimize your workspace. So there are some tips as well that only apply to databases. We've seen a few of those already. Whenever possible, when reading from a database, push filtering to the database itself. You can use where clauses. You can also sort the data on the database. You can request just specific attributes. You can get subsets of your data. It reduces the amount of processing that FME would then have to do on your own machine. Sometimes all of that's available within the database reader for that particular database format. Quite often, you'll end up having to use a SQL transformer instead. The SQL executor has an initiator, the SQL caller does not. So the SQL caller, I believe that's what it's called. Let me just double check. SQL creator, sorry, not SQL caller, SQL creator. That has no initiator, basically just runs that SQL query at the beginning. This is very much like using a feature reader transformer, but without the initiator. And then if you're good with SQL, you can grab very specific things. The queries will run faster on indexed fields. If queries are slow, perhaps test an external query tool to see if FME is in fact the bottleneck. When writing to a database on the network, be aware that the network overhead also affects performance. This actually applies to reading as well. So the network traffic is something to be aware of. The features per bulk write, this is how much FME caches while waiting to write. Features per transaction, when a commit command is issued, it causes a delay. So you can decide how many features will be per transaction. For example, if you have a feature per transaction of 1, then each and every feature is committed individually. Now, this can be helpful if the process fails, only the last feature is lost, but that will take, each of those transactions takes time, so it could be a slower translation overall. Having an index on your database speeds up reading, but it does slow down writing. So sometimes it's worthwhile to have this as some other process. The index doesn't always have to be there. Perhaps do it at some other time if necessary. Writing and table creation. Updating a table takes time, so keep that in mind. Sometimes it's better just to truncate what you have or drop and create, and then just rewrite everything. Scalability can also improve performance, and that's where FME Server and FME Cloud come in. FME Server is handy because for someone like me, I'd be running all my translations on a laptop. That's not a particularly powerful machine. An FME Server installation would be likely much more powerful and can run many translations in parallel. If you don't have the budget to spend on an FME Server license and the required hardware, especially if you're doing a process that is only being done infrequently, then FME Cloud may be worth a look. It is FME Server offered as a pay-as-you-go service. You can also use FME Server for bulk translations. You can, within a workspace, use transformers like the FME Server Job Submitter. This allows you to link together multiple translations and manage that all within a workspace. That can also be used if you have multiple files to process. You can share the load across multiple server engines. Each file to be processed will fire off an FME Server Job Submitter to submit that particular job for that particular file. Okay, a little bit about batch processing. Again, you can do a lot of batch processing using FME Server itself. FME Server is capable of watching particular folders or FTP sites, S3 buckets, things like that. When files are added to it, it can automatically launch a translation of it. So that's how you can do this on FME Server. But sometimes you'll just want to do it on your own desktop machine using FME Desktop. So batch processing is basically running the same workspace multiple times, each run with a separate data set. There's a few ways that you can accomplish batch processing with Workbench. One of them we kind of saw earlier. We can run this from the command line, which means that you could have a batch file where you just have all these entries for what you need. And when you launch that up, it will run the first one and wait till it's finished before it runs the second one. So it's just a batch file with all those command lines in there. If you want to get fancier, you could use a for in do loop within a batch file. So that's one way of doing batch translations. That's typically the way I've ended up doing them in the past. But Another useful thing to use is the Workspace Runner transformer. Let's say I have this workspace here. I want to read in my ortho photos, process my neighborhoods against them, clip them, send it out, etc. We get new ortho photos each week. So what I could do is have a batch file and schedule it. Or what I can do, if I want to do this for each file, I can actually use a path reader. This is a directory and file path reader. What this does is it creates a feature for each file. The attributes are just the location of that file, the path. I then pass that to this workspace using my Workspace Runner. This combination here, a directory and file path name reader and a Workspace Runner, is the equivalent of a for in do loop in a batch file. But it's all within Workbench. So then within the Workspace Runner, I can tell it, run this workspace, and then I pass in my published parameters, and that's the path to the file. Now, what can be handy with this is that it can use multiple CPU cores. FME itself, when you run it, it tends most of the time to just use a single core. With the Workspace Runner, I can actually be running multiple FME processes, each one using a separate core. So you're making better use of your CPU. So if you're looking to batch translate, my recommendations are, if you're familiar with batch files already, use batch files. If you're not familiar with batch files, use the Workspace Runner. The next up is the batch deploy. Under the run command here, there we are. So under run menu, we have this batch deploy. The batch deploy creates a TCL file and a batch file. Basically, it's taking that for in do loop and setting that up for you. I greatly dislike the batch deploy option here. It uses absolute paths, which means that if you try to move this batch file somewhere, it won't work. Also, it does not play well with Esri shapefiles for whatever reason, and chances are you're going to be reading in shapefiles at some point in time. So I'm not a big fan of batch deploy. You can give it a shot if it works for you, fantastic, but ultimately, in my experience so far, using actually the Workspace Runner can be the easiest way of handling things, because then you can also do additional tasks afterwards if a translation fails, if it doesn't fail. You can also do other tests on your source data. It's just a lot more expandable. Okay, so this brings us to exercise 4. Let's see, where are we? This is the last exercise of the day. So let's work through this. There's 2 ones that we can do here. We have a PostGIS database or a file geodatabase. Let's work through it together using the PostGIS database. You can then take a look at the file geodatabase on your own if you so desire. I'm going to grab the Start Workspace here, because this also allows me to show some other things that we can set up. So I'm going to paste this out. And open this up. So we're going to open up FME Data 2019, Workspaces, Desktop Advanced, Workspace design, exercise 4, PostGIS, begin. Okay, so let's take a look at what we have. We have our PostGIS postal addresses. We have a garbage schedule. This is a file geodatabase file. We have a tester. We're looking for a particular address. We have a point on area overlayer, an HTML report generator, writing out to HTML. So we've been handed this workspace. Let's see if we can run it. We'll run it. This is something which you may or may not have seen so far in Workbench. Reading in a database. When we want to read in a database, we store these connection credentials as a encrypted file. I think it's encrypted, or at least it doesn't get handed around when you hand around the workspace. That allows you to more carefully keep possession of your username and password for databases. So that information is not stored within the workspace itself, which is handy because the workspace itself is just a plain text file. We're going to want to add a database connection. Oh, wait, FME training database connection. I'm trying to think if I already created one or not. I might have. Let's add a database connection. So let's create the database connection. You can actually see everything here. This should all work. Our host is postgis.train.safe.com. I'm just going to cancel out of this actually for a second here because I want to move it over there so I can see it. Sorry, bit of a coughing fit. So I'll add a database connection. Name. PostgreSQL. The host. postgis.train.safe.com. Port 5432. The database is FME data. The username is FME data. The password is also FME data. So the database username and password are all the same thing. At least it should be. Let's find out. Let's hit test. Okay, it says it successfully connected to the database. Let's save that. And let's run the translation. So it just read in 6 from the garbage schedule, 13,000 from the postal address, and ran it through a tester. Oh, I didn't specify a particular address. So just use an address ID, 12729. Let's run that again. Prompt and run. So choose the prompt for user parameters because we want to be able to request a particular address ID. So it's using an address ID, which is more appropriate for the geodatabase. Let's give it 127.209. Run that again. And that took 4.7 seconds. If we were to inspect the HTML, we'll skip that for sake of time. this is what it would look like. Garbage collection day, the property, the address, garbage zone, collection day. And it actually ran a little bit faster for us, 4.7 seconds. Again, because this is a database on the internet, your own internet connection will affect that. Well, not your own, actually, because you're running this on an Amazon EC2 machine, but the internet connection for the Amazon EC2 machine will affect it. So instead of using a tester, what we could use instead is a where clause within this PostGIS feature type. So let's open that up. The where clause, notice that the where clauses here can often vary. Some databases want quotation marks around attributes, some don't. So you have to be familiar with your particular database. Sometimes a quick Google search can help you. I find that quite often if you're working with Oracle a lot, if you then want to use SQL Server instead or PostgreSQL, sometimes the syntax can be somewhat different. Now, the where clause, I can use the text editor here. That'll make it a little bit easier. We have our database tables. So address ID equals, and what we want this to equal is the published parameter address ID. So what I did here is I grabbed from the database table, postal address, I grabbed my address ID, and then in the published parameters here, I grab the address ID. Hit OK and OK. I can now delete my tester here. And when I run the translation again, I'll grab 127209. That took 4.7 seconds last time. And this time it took 2.7 seconds. So I shaved 2 seconds off the translation that time. So again, being able to push that query to the database can greatly improve performance because you're reading in less. And as we saw earlier when we were doing the performance evaluation, the reading and the writing took the most amount of time. The actual processing itself was fairly quick.